You're asked to solve each of the following equations by first expressing each side with the same base. Give answers using fractions and not decimals. So what it means by expressing each side with the same base is that 8 and 32 can both be changed into some sort of exponent and with the same base. For example, 8 I know is 2 to the power of 3 because 2 times 2 times 2 equals 8. So I'm literally just going to rewrite this problem as 2 to the power of 3 to the power of x plus 3 because I know 2 cubed is the same thing as 8. So all I did was replace 8 with 2 cubed. Now I want the base to be the same on the other side. So for 32, that's actually going to be 2 to the power of 5 because 2 times 2 times 2 times 2 times 2, 4, 8, 16, 32. So now I'm just replacing 32 with 2 to the power of 5. So all I did for my first step here is to get the left and the right side. I didn't change the value, I just changed the way that it looks because I got rid of 8 and replaced it with 2 cubed. I got rid of 32, replaced it with 2 to the power of 5. And now I have two exponents with the same base. So to solve this, because I'm looking for x really, I'm going to use my power rule. When I have a power of a power, I multiply them. So just like if I have x squared to the power of 3, that would be x to the power of 6 because I multiply them. I'm doing the same thing here, and it becomes 2 to the power of 3x plus 9, because I'm distributing that, equals 2 to the power of 5. And now the math gets very simple because all I have to do here is, since the bases are the same, then I know that the exponents have to match also. So 3x plus 9 has to equal 5. And then I just solve. So subtract 9 from both sides. Equals -4. Divide by 3. And my x value is equal to -4 over 3 as my answer. So that's the same process we're going to use on all these. So for the second one here, 27 is the same thing as 3 to the power of 3. And then 1 over 9, this is going to test our negative exponent skills, is the same thing as 3 to the power of -2. And so again, the hardest part of this problem, in my opinion, is finding what is the base going to be that matches. I see 27, I see 9, so I know that those are both exponents of 3. And then just figuring out that this fraction becomes -2 is the hard part. So now from here, I use my power of a power rule to multiply those, and I get 3 to the power of 6x equals 3 to the power of -2x plus 2. And since I have a common base now, I set these two things equal to each other. Add 2x to get 8x equals 2. Divide both sides by 8, which gives me 1/4. So my x value here is 1/4. And last one here, 1 over 125 is 5 to the power of -3. 1 over 25 is 5 to the power of -2. And I'm going to use my power of a power rule to multiply these and get 5 to the power of -6x plus 9 equals 5 to the power of -2. My bases are the same, so I can set the exponents equal. And then I can just solve. And x is going to be equal to, let me see, oh, I did that wrong. -2 minus 9 is -11. So positive 11 over 6. Let me double check my answers here and make sure I did all that right. Yeah, so I have, for my final answers here, I had -4 thirds, 1/4, and 11 over 6 as my final answers. Again, the process is just make the bases the same, use the power rule to multiply, set the exponents equal to each other, and solve for x.